Hello, my name is Linda, and this should be your first session for arithmetic, and I will be working with understanding fractions today. That should be your very first packet. So let's get started. I'll share my screen with you here, and this is the first packet. So if you want to pause the video and get the packets, you can work along with me. That would be great. Anytime you need to pause or rewind the video, you're welcome to do that. This first packet is just getting you to understand what fractions are. So I'm going to pull up my tools here. So let's scan a little bit. So this just kind of explains what a fraction is. So basically that the fraction has a numerator, that's the top number, and a denominator, that's the bottom number. So if you have, for example, this circle here, you have 3 of them colored in. I hope you can tell that these are all supposed to be colored in here. This one's colored in, this one's colored in, and this one's colored in here. So then you have 3 parts colored in. And how many parts is the circle cut into? 4 parts. So this fraction is 3/4 of the parts of the circle are colored in. So let's take a look at a few below that. And I'd like to look at number 4. Let's look at row 4. So let's kind of close out and cover up all these other things that can be distractions for our visual learning on a computer. So let's cover these up as best we can and just have that open. Okay. So now let's look at number 4 and see if we can tell what fractional part of that circle is colored in. So if I look, I count how many parts it's cut into. That's my denominator. 1, 2, 3, 4, 5, 6, 7, 8. It's cut into 8 parts. That's the bottom. And my numerator is how many are colored in. So the ones with the X's are the colored in ones. 1, 2, 3. So 3/8 of my circle is colored in. Okay, let's look at number 5. If you can do this. If you want to ever pause the video and do it ahead of me and then check your work, that's a great way to learn too. So we have how many parts is it cut into? 1, 2, 3, 4, 5 parts. And how many pieces are colored in? 2. So 2/5 of that, is that a pentagon? 2/5 of that pentagon are colored in. Next one is a triangle. How many parts do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9 parts. So 9 is my denominator. My numerator would be, how many are colored in? 1, 2, 3, 4, right? So 4/9. Okay, so that's what you're going to be doing on that page. I'm going to move forward a little bit. I'd like to go to talking about how to write fractions when you're given words instead of pictures. So let's clear our drawings and let's scroll down here to some of these word problems, writing fractions from words. So let's look at number 1. Let me just get rid of some of these other ones here that we don't need right now. Oops, that's not what I wanted to do. Redo. I've got to find my rectangle. Here we are. Okay, so let's hide this. Okay, the first one says a foot contains 12 inches. 5 inches is what fraction of a foot? So our top number is our part. Our bottom number is our whole. So we have a total of, let me use red this time. I think that's easier to see. We have a total of 12 inches in 1 foot. And how many inches is 5? 5/12 of a foot. So there's that one. Okay, clear that one. Let's try number 7. So go to 7 here. And again, I've got to get my little box. Okay, let's look at number 7. Erlene wants a jacket that costs $60. She has saved up $43. What fraction of the amount that she needs has she saved? Okay, so the whole is on the bottom. That's your numerator. So let's first draw a line here. So we have a fraction. Then she has a jacket that costs $60. That's how much it costs in total. That's your whole. That's your denominator. She had saved $43. What fraction of the amount that she needs has she saved? So she has saved 43/60 of the amount. Okay. Try to erase that one. This erases everything when I do that. Okay, number 13. Let's go on up to that one. And we'll put another box there. And I'll do another box down here so we don't have all that distraction. Okay, number 13. Madge has typed 77 pages of a report that contains 280 pages. What fraction of the report has she typed? What is your bottom number? What is your whole? She has a total of 280 pages. And she has typed, extend my line a little bit, 77 of those pages. So 77 280s. Okay, all right. Clear my drawings. And now let's move on a little bit and talk a little bit about improper fractions. Okay, I want to talk a little bit about the different types of fractions or the forms of fractions. This is on page 13. We're going to discuss what's on that page. So I'm going to go to a Word document here. And I'm going to talk about a little bit. There's three kinds of fractions. There's the improper fraction. There is the mixed number. And there is the proper fraction. Proper fraction is what we've been working with so far. With a proper fraction, you have a top number, a numerator, and a denominator, like this. And that is proper because the top number, right here, is smaller than the bottom number. So a fraction is a portion or a part of a whole. So this actually shows 3 parts out of 5, so it's part of a whole. So that is the proper way to write a fraction. A mixed number is where you might have a whole number and a fraction with it, 2 3/5. Oh, my 5 didn't work out. Let's try that 5 again. 2 3/5. Okay, that's a mixed number. Now, what is an improper fraction? So if I was at the store and I started screaming really loud, people would say I'm acting improperly, right? They're going to say something's out of whack, something's not right with this person. She's screaming and yelling in the store, right? So that's not proper. So an improper fraction is not the way things are supposed to be. So if I had something like 20 thirds, something is out of whack. A fraction is normally a part of a whole. This is saying you have 20 parts, but they're cut into only 3 pieces each. So this is an improper fraction because the top number, the numerator, is bigger than the bottom number. So 20 is greater than 3, so this is considered an improper fraction. Okay, now we can look at some of the examples in on your pages here. Let me just go back and pull that back up again. Okay, so this is what that page 13 talks about. So here are some examples where you have to list something as proper, improper, or mixed. So P for proper, I for improper, and M for a mixed number. So let's take a look at row 1. I wanted to do row 1, 9/6. That's the first one. So let's take a look at that one. This is the one I'm looking at right here. So the top number, is it bigger or smaller than the bottom? It is bigger. So this one is called an improper fraction. Something's not right with it. It's improper. So that gets a big old I. How about 8/30? What would that one be? Go and circle that one now. How about 8/30? What would that be? Yes, the top number is smaller than the bottom number, so that is considered a proper fraction. So we're going to put a P there for that one. Okay, what about the next one? 4 1/2. What is that called? Right, it's got a whole number 4 and a fraction part 1/2, so that is a mixed number. And then what about number 10/10? This one right here. Which one is that? Is that an improper? Is that a proper? Or is that a mixed number? Well, is it improper? Well, the 10 is not bigger than the other 10, right? They're both the same. They're both equal. So what do we think? Is it proper? Could it be written that way? Do you normally see a fraction 10/10 written like that? Not normally, right? So we are actually going to call it improper. And it is improper because you can rewrite 10/10 as 1, right? Any number over itself is 1. So 10/10 is 1. 20/20 is 1. 1,000 over 1,000 is 1. 1,000,000 over 1,000,000 is 1. They all equal 1. So on this part of the packet here, you're going to be writing IP, M, or, IP or M. All right, let's go on from there. I think I want to go back here for just a minute, and I want to talk about the greater than or less than sign. So if you have a number 5 and you have a number 10, you have two signs, a greater than and less than sign. I'm going to put one each direction. And you have to decide which one to put in this circle right here. Is it going to be a greater than or less than sign? So we know that 5 is less than 10, correct? So we are going to put the less than sign in. So it's going to look like this. And the way I like to look at it, here's my circle here. The way I like to look at it is I like to say that the mouth of my little Pac-Man guy here eats the bigger number. So the 10 is bigger, so my open mouth of my Pac-Man is going to eat the 10. So if you were to write, next one would be like, let's try this, 12 and 6, which way is your sign going to go? This one says 5 is less than 10. Now what are we going to say? Yeah, 12 is greater than 6. And again, my Pac-Man guy's mouth is going to eat the bigger number, so it's going to open towards 12 that way because he's bigger than 6. Okay, so if we were doing that, I want to show you a couple other things. With fractions, you can have, let me just clear my drawings for the moment, you can have a number such as 4 over 8. Now, what is half of 8, the bottom number? 4, right? So if 4 is half of 8, this number 4/8 is really the same as 1/2 because 4 out of 8 is half of it. If I had a pizza cut into 8 pieces and I ate 4 of them, I would have eaten half of the pizza. So what about if I gave you 5/8? 5/8. Is that exactly half, less than half, or more than half? What do you think? It is more than half. Why? Because 5 is bigger than 4, which is half of 8. So 5/8 is greater than 1/2. So my open mouth is going to go towards the bigger number. Let's try one more. What if I gave you 3/8? Is that more than 1/2, less than 1/2, or equal to 1/2? Well, 3 is less than 4, which is half of 8. So 3/8 is less than 1/2. Okay, now let's go back to our paper and let's take a look at page, I believe it's 14. Yes, look at page 14. So on example 1 here, right here, It says circle the fractions that are equal to 1/2. So remember, you're going to take whatever half of the denominator is. If that number is on top in the numerator, that's half. So how about 4/9? Is that half? What's half of 9? Right? 4.5 is half of 9, or 4.5, right? So 4 is a little under that, so that's not half. That's not equal to half. However, what about 6/12? 6/12. Yes, half of 12 is 6, so 6/12 is 1/2. What about 9/18? What's half of 18? 9. So 9/18 is also equal to 1/2. What about 7/15? What's half of 15? 7.5, right? So 7 is a little under that, so that's not equal to half. What about 3/7? No. What about 8/16? Yeah. And the last one, 12/24. That's exactly half, right? 12 is half of 24. So there we go. That's example 1. Let's clear these. Let's go on to number 2 here. Circle the fractions that are less than 1/2. Well, I'm going to let you do those. We kind of talked about that just a few minutes ago. I'll let you give those a try. I'm going to show you one of them. So 2/7, because 2 is way less than half of 7, that one is less than 1/2. Okay, there's more. And then 3, circle the fractions that are greater than 1/2. So let's find one that's greater than 1/2. Let's look at the first one. Is that greater than 1/2? 3 is more than 2, right? Because 2/4 would be exactly half. So 3/4 is greater than 1/2. So you would circle that. Let's take a look at, it's telling you what the greater than less than symbol means. Now we want to put in here, we want to put greater than or less than here. So 3/5 is greater than 1/2 because 3 is more than half of 5. 2.5 is half of 5. What about 8/16 and 1/2? What would that be? Right, that's exactly 1/2, so that gets an equal sign. Right? What about 7/20 and 1/2? What's half of 20? 10. So 7 is less than 20, so 7/20 is less than 1/2. So the open mouth has to go towards the half, which is bigger. So I'll let you try the last one on your own. And I want to move on from there to reducing fractions. So for reducing fractions, we're going to talk about that. You can go ahead and read that on your own if you'd like after the video. I'm going to go right on to trying to do some reducing of fractions. Let's get a little bit of white space. Let's do row 1. I'm going to hide all this other stuff that we don't need. Okay, so we have 6/12, 7/28, 3/9, 9/45, and 6/48. And they want us to reduce it to lowest terms. So we have to find a number that will divide in both the top and the bottom. It has to be the same number. So we know that 6 will divide into 6, right? And we also know that 6 will divide into 12, right? So we can divide the top and the bottom, and make a little division sign here. Top and the bottom by 6. So 6 divided by 6 is equal to 1. And 12 divided by 6 is equal to 2. And you might have already known that was a half, just because you saw that 6 is half of 12, right? So 7/28, we're going to divide the top and the bottom by the same number. So what number will go into both? Well, it has to be a 7, right? 7 divided by 7 over 28 divided by 7 gives me 1 on top. 28 divided by 7, 4 times 7 is 28. So there we are, 1/4. What about 3/9? Well, we're going to divide the top and the bottom by 3. You can never divide by more than what the smallest number is in the fraction, right? So divide top and bottom by 3, and you get 1. 9 divided by 3 is 3. 1/3. 9/45. What are we going to divide there? my little dividing sign there. And as you get good at this, you can probably just do it in your head, but at first it's good to just write it all out. So I'm going to divide by 9 on top and 9 on the bottom. That will give me 9 divided by 9 is 1. 45 divided by 9. 5 times 9 is 45. So that one gives me 1/5. So I think you get the idea on those. Let's clear the drawings. 1, 2, 3, clear. And let's move on to row, let's try row 5. So let's pull this up here and cover up the top and cover up the bottom. Okay, let's look at row 5. 75/80ths. What can I divide into 75 and 80? Well, I can't divide 75 into both, right? So we could try, sometimes trial and error. Let's try 5 on top and 5 on the bottom. So 75 divided by 5 is going to give me 115, right? It's going to give me 15. And on the bottom, 80 divided by 5 is going to give me 1 time 30, 16, right? So 15/16 will give me the reduced number. And I know I'm in lowest terms because I have an odd number on top and an even number on the bottom. That doesn't always work. That holds true with most numbers, except if 3 divides into top and bottom, you could end up with 2 odds or 2 evens on top. So, but for the most part, odd and even rule works well, and that means you're at the lowest you can go with your fraction. Let's try 420 divided, or 420 over 480. Well, when you have 2 zeros in there, like this on the ends, you can first of all cross off the zeros. Just get rid of them. And now you can say 42 and 48. What will divide into both? Well, I know that 6 divides into 42, and I know that 6 divides into 48. So I get 42 divided by 6, 7, and 48 divided by 6, 8. So 7/8. Okay. If you're shaky on your multiplication facts, a good idea would be to get a multiplication chart. We have some at the tutoring office. And you can then start memorizing. Try not to use the calculator because you won't be able to on the test, but you can start using that multiplication chart right now so you can start getting some of those facts memorized. Okay, 72/90ths. 9 times 8 is 72, so I'm going to divide the top by 9 and the bottom by 9. And I'm going to get 9 times 8 is 72, so I'm going to get 8 on top. And I'm going to get 10 on the bottom, right? Because 90 divided by 9 is 10. But now look at what happened. I can still divide more. How do I know that? Well, I have 2 evens. I have an 8 on top and a 10 on the bottom. So I could have divided with a bigger number, right? So if that happens, you just keep dividing. So I know that I can divide a 2. I'll draw my little symbol here. A 2 on top and a 2 on the bottom, right? And then I'll get 8 divided by 2 is 4. And 10 divided by 2 is 5. So I get 4/5. So I could have divided top and bottom by, it looks like 18 originally. The bigger number would have been 18. But if that happens to you, then you just divide a second time. So, all right, let's move on from there. And let's take a look at some word problems. We'll scroll down here. Let's look at problem number 11. So, get rid of all of this and get rid of number 10 there. Let's look at number 11. It says 10 ounces is what fraction of a pound? Okay, easy peasy, right? So 10 ounces is what fraction of a pound? How many ounces in 1 pound? It tells you 16, right? But now we're going to have to reduce this fraction because it's not in lowest terms. So what can I divide the top and the bottom by? Divide top and bottom by, we can try 2. right? And see what we get. We know they're both even numbers. We know 2 will always work when you have even numbers. 10 divided by 2 is 5. And 16 divided by 2 is 8. So the answer is 5/8. That's number 11. And let's do number 19. Pull this up. Okay, the West Side Community Center needs $24,000 for their summer youth program. So far they have raised $15,000. What fraction of the total cost have they raised? So part over whole, they've partly raised some. They've raised $15,000. That's the part. And the whole is they need a total of, nice straight line this time, total of $24,000. $24,000. Comma. Okay, now we have to reduce that fraction. So first of all, I notice there's a lot of zeros that can be matched up. So I can erase this 0 and this 0, right? Cross out this 0 and this 0. And I can also do that with this 0 and this 0. So now I'm left with 15/24. So I know that a 3 will divide into 15. And I know that a 3 will divide into 24. This is one of those examples too where I said that sometimes you can have an odd and an even on top and it can still divide further. So this is an example where there's an odd number on top and an even number on the bottom, but yet it's not in lowest terms. That's because a 3 will divide into both. So that's the exception to the rule of 3s. If a 3 will go into both top and bottom, you could end up with an odd and an even and still not be in lowest terms. So 15 divided by 3 is 5. And 24 divided by 3 is 8, right? 3 times 8 is 24. So that answer is 5/8. I think that's what we got for the last one too, wasn't it? Okay, I'm going to clear these. Let's go on here. This part is called raising fractions to higher terms. So we're going to skip past that and go right to the problems here. So what they want to do here is, for example, let me just get rid of some of this extra stuff in here again. We know what we're looking at here. Okay, so we have 4/5 is equal to something over 30. So we have to say, what can I multiply 5 by to give me 30? 5 times 6, right? So I have to multiply by the 6 on the top. So it becomes 4 times 6 on top. So 4 times 6 is 24. So 4/5 is equal to 24/30. So what you're doing is you're going the opposite way. When you were reducing, you were getting smaller. Now you're getting bigger. So 9/10. What number can I multiply 10 by to give me 20? Right, 2. So I'm going to multiply the top by 2. And like I said, eventually you'll get where you can just do this in your head. So 9 times 2 is 18. So 18/20 is equivalent to 9/10. How about 1/6? 6 times what gives me 18? 6 times 3, right? So I have to times by 3 on top. So 1 times 3 is 3. So 1/6 is equal to 3/18. If I were to reduce 3/18, I would get 1/6. And 5/8 is equal to what? 32s. 8 times what gives me 32? 8 times 4, right? So I times 4 on the top, and I get 4 times 5, or 20. So 20 over 32. That's how to raise a fraction to a higher power. Okay, clear those. And let's look at changing improper fractions to whole or mixed numbers. So I'm going to go past all of this. And I want to draw a little bit of a picture for you guys. Let's clear all this out of the way for the moment. So we have 14/8. So let's see what that means in terms of a drawing. So let's make pretend pizzas here. And these are rectangle pizzas because circle pizzas are really hard to divide into equal pieces. So I'm going to use that. So we need a pizza cut into 8 pieces. So one, try to be equal with these. Just imagine that they are, even if I don't quite get them equal. 1, 2, 3, 4, 5. How many do I have? Do I have 8? 1, 2, 3, 4, 5, 6, 7. Oh, pooey, I need one more. Okay, so we're going to do this. We're going to make this just a little bit bigger. And we're going to have one more. Okay, that's 8 pieces, and they're supposed to be equal pieces. So I need, let's say, so this is a pizza, and I have cut it into 8 pieces. But I have eaten 14 pieces, right? This is an improper fraction, isn't it? So what I need to do is draw another pizza because I don't have enough pizzas to illustrate my example right now, do I? So I have to draw another pizza cut into 8 pieces. So let's do that. 1, oh, I want the line. Line is straighter. 2, 3, 4, 5, 6, 7, 8. Okay. Now, how many pieces have I eaten? The top number is how many pieces I've eaten. So I have eaten 14. So I've got to color in. I want to color that in. Let's see if I can do that. I have eaten 1 piece here, 2 pieces, 3 pieces, 4 pieces, 5 pieces, 6 pieces, 7 pieces, 8 pieces, 9 pieces, 10 pieces, 11 pieces, 12 pieces, 13 pieces, 14 pieces. And you might wonder why I'm doing this, but I'm trying to show you an illustration of what you're actually doing mathematically. So how many whole pizzas have I eaten? Well, this is a whole pizza right here, right? The first pizza. So I've eaten 1 entire whole pizza. And how many pieces have I eaten of the second pizza down here? Count the blues. 1, 2, 3, 4, 5, 6. I've eaten 6 pieces. And how many pieces is my pizza cut into? 8, right? 1 and 6/8. However, 6/8 can be reduced to 1 and 2 goes into 6 3 times. 6 divided by 2, and 8 divided by 2 is 4. So that answer is 1 3/4. So I'm changing my improper fraction, my 14/8, into a mixed number of 1 3/4. So I have just shown you mathematically how that works. Now here's the shortcut, because you're not going to be drawing pictures for every single improper fraction that you're doing. So what you're really doing is you are doing a division problem. So you are saying you have 14 pieces that you've eaten, and they are cut into 8 pieces per pizza. So how many 8s go into 14? Just 1. 1 times 8 is 8. Way back to remembering long division. 14 minus 8 is 6. That's my remainder, right? I'm going to bring my remainder up here next to my whole number, and I'm going to say that's the part that of the whole that I've eaten on the second pizza. So 1 and 6/8. Isn't that what we got over here to begin with? Yes. And then we reduce 1 and 6/8 to 1 and 3/4. So that's the mathematical way that you reduce and change improper fractions to mixed numbers. So let's try this 37th here. Let's try, circle that one here. Let's give that one a try right there. So we could draw a picture. We would have to draw pizzas cut into sevenths. So let's do one more of a picture thing here, just so we can see what we're doing. So we're going to have 7 pieces this time because the bottom number is sevenths. 1, 2, 3, 4, 5. I think I need more. 1, 2, 3, 4, 5, 6, 7. Okay, there's our 7 pieces. And we need to color in 30 of them. Well, you can already tell I'm going to need a whole nother pizza, right? I wish I could just copy and paste, but I can't. So we're going to draw another whole pizza here, like this. And we're going to get 1, 2, 3, 4, 5, 6, 7 with the 2. So I now have how many pieces? 14, right? I need to get up to 30, so I'm going to have to do that again, right? So another pizza. Am I going to have enough there? Now I'll have 3 times 7, I'll have 21, right? I still need more, don't I? So I'm going to need another pizza besides that. So I'm going to have to go again and draw another one. So now am I going to have enough pieces? I got to color in 30 pieces, right? Oops, that one's crooked. Fix that one. So am I going to have enough, or do I have to draw another pizza besides? Right, I have to draw another pizza, right? You can tell that I'm going to draw one more pizza. And let's do that. Okay, one more pizza cut into sevenths, equal pieces or thereabouts. Okay, so now we go to coloring in the pieces that we need. We need 30 pieces, that's what our top number is, so we have to color in 30 pieces. So we're going to color in all of these, of course. This is 7, right? There's 7. Another 7 is going to give us 14. Another 7 is going to give us 21. Another 7 is going to give us 28. We're not there yet, right? And how many more pieces on the bottom do we have to color in? We have 28 right now colored in. Right, 2 more. 29 and 30. So now we say to ourselves, how many pieces or how many whole pizzas have I colored in? 1 whole, 2 wholes, 3 wholes, 4 whole pizzas have been colored in. And how many pieces of the last pizza? 2 out of, how many are they cut into? 7 pieces. So changing 37s over, you get 4 and 2 sevenths, which is the same as the mathematical way of dividing. Take the top number and put it on the inside. So 30 is on the inside and 7 is on the outside. So you're seeing what you're doing is you're just dividing your 7 pieces per pizza into 30 pieces to see how many wholes you get and how many are left over. So 4 times 7 is 28. That's how many whole pizzas we're going to get. And then we subtract 30 minus 28 whole ones colored in. And we're left with 2 as our remainder. That gets put up to the top and becomes 2. That's a bad crooked one, but 2 sevenths. So 4 and 2 sevenths. We got it both ways, right? So I just wanted to show you how that works. And now let's go the other direction. Changing mixed numbers to improper fractions. So let me show you how this one works. I'm going to cover up some things here again. And I'm going to do pictures again because it's important to see what we're actually doing and to visualize it. So this is 2 3/4. So this time I'm going to do it this way. I'm going to have my pizza here. This one is only cut into fourths though, right? So 1, 2, and that's way too big. 3, 4. Shrink it down just a little so it looks better. Okay, and I need, this time, I need 2 whole pizzas. That's what it's telling me. So I need to have 2 holes. So I have to draw another one. Okay, let's draw that. 2 whole pizzas. 1, 2, 3, 4. Okay, and then I have a part of a third pizza, right? So I have to draw another pizza. I'm going to draw one more pizza cut into fourths. 1, 2, 3, and 4. Okay, now I have to color in 2 whole pizzas. That's what the 2 says. So I have to color in this whole pizza here, right here. And then the fraction part says I have to color in 3 more out of the 4. So 3 more pieces. Now I want to change 2 3/4 to an improper fraction. So what I'm doing is counting up how many pieces I've colored in. So let's count. We have colored in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces. So that's my top number. And my bottom number is how many pieces my pizza was cut into, and it was cut into fourths and stayed fourths the whole time. So changing a mixed number over to an improper fraction looks like that. That's just the opposite what we just did before this. So now, here's the mathematical way of doing it. So we really, if you look at it, we have pizzas cut into fourths right here, and we have 2 holes. So that's 2 whole pizzas times 4, right? So 2 times the bottom number, 4, is 8, plus the leftovers on the third pizza, 3 more. So that's 2 times 4 plus 3. So the mathematical shortcut is to take the whole number times the bottom and add the top. Okay, that is the mathematical way of doing this without drawing pictures. But I just wanted you to see what we were doing visually. So this one, the next one, 1 4/7, you're going to take the whole number 1, times it by the bottom, 7. 1 times 7 is 7. And you're going to add the top. 7 plus 4 is 11. And then the bottom number is going to stay 7. Okay. Let's try this one. 5, whole number times the bottom, 3. 5 times 3 is 15. Plus the top number is 1 more, so 16. So 16, and the bottom number is going to stay thirds. Okay. So let's do one more. Whole number times the bottom, 6 times 7, 42, plus 2 more, 44, right? And that stays sevenths, 44 sevenths. Okay. All right, and I believe we may be at the end of our page, and we are. So I'm going to stop my share, and I hope that you learned some things from this lesson, and I will see you on your next lesson. Good luck. Bye.